guys, let us continue our solving trigonometry. We are now in part 7, number 46 problem. Find the cotangent theta if sine theta is equals to 1/2 and is in the second quadrant. So to solve this problem, we're going to have a procedure. One is determine the sine of the tangent in the second quadrant. So this is the Cartesian plane introduced by René Descartes, mathematician, that in the second quadrant, third and fourth, the sign of the coordinate, the abscissa is negative and the ordinate is positive. So in this situation, tangent theta is equals to sine theta over cos theta. This will be the formula. So our sign here, the sign is positive, and over the cos theta will be the negative. So then if we're going to divide positive divided by negative equals to negative. So the sign of tangent theta at the second quadrant is negative. How about the cotangent? Cotangent is equals to cos theta over sine theta. Why is it negative? Because the cos is our abscissa. And why is it the sign is positive? Because our sign is the ordinate. Then we're going to divide, and if our concentration is only for the sign, the cotangent theta is equals to negative divided by positive equals to negative. So therefore, this is to prove that the tangent theta and the cotangent theta the same negative and the second quadrant. Okay, our next number 2 procedure is determine the fundamental identity element of the trigonometric functions. For example, cos squared theta plus 1 equals to cotangent squared theta. So this will be the identities that we are going to use in this kind of problem, and we're going to solve now upon knowing the first and second procedure. Next, our solution is step 1. Since the cotangent theta if sine theta is equals to 1/2, we will use first the cosecant theta equals to 1 over sine theta in order to solve first the cosecant. Because in this formula that we're going to use, the fundamental, we will use the cosecant squared theta. So that's why we need to know the value of cosecant before we go on to cotangent squared theta. So cosecant theta is equals to 1 over the value of sine theta is 1/2. Then reverse computation, reciprocal method, it becomes now the answer is cosecant squared theta is equals to 2. Now, step 2, we will use the cosecant squared theta plus 1 equals cotangent squared theta. This is the fundamental identity that we're going to use now. And the value of cosecant squared theta is 2, positive 2. So that's why we have 2 squared plus 1 equals cotangent squared theta. Theta means the angle. This is the angle at the origin. Then we're going to extract the exponent. 2 times 2 equals 4. Then copy plus 1 equals cotangent squared theta. 4 plus 1 equals 5 equals cotangent squared theta. Then cotangent squared theta is equals to 5. We reverse only. When you are going to reverse, no need to change the sign. Then we're going to find the square root of both sides, then cancel. The remaining now is cotangent squared equals positive and negative square root of 5. This is the problem. Now, what is now the sign of the cotangent at the second quadrant? Based on our computation and procedure 1, is the answer for cotangent theta, the sign is negative. That's why we're going to choose cotangent theta equals to negative square root of 5. Okay guys, number 47 problem. Simplify the expression sine theta over 1 minus sine theta. How to simplify this? So we have to follow the procedure. Number 1, we have to conjugate the expression, this denominator, and solve and simplify the given. So our solution, let us write the given. Sine theta over 1 minus sine theta is equals to sine theta, copy first, over 1 minus sine theta. Then if we're going to conjugate, if this sign negative, it becomes now positive. So we're going to multiply over with 1 plus sine theta, and also 1 plus sine theta. The same as the numerator and denominator. Then after that, we're going to multiply directly the numerator and the numerator. So sine theta times 1 equals sine theta, plus sine theta times sine theta equals sine squared theta. And multiplication, we're going to add the exponent. That's why it becomes sine squared. And the denominator, we have to do just only multiply. Then the sine theta plus sine squared theta, the numerator, so we have just only to copy. And this denominator, we're going to multiply. Take note, if the same, given 1 sine theta, and the difference is only the negative and positive, so we have to do, we can directly multiply this. 1 times 1 equals 1, and negative times positive equals negative, and sine theta times sine theta equals squared theta. Why? Because we're going to add the exponent of the expression and multiplication. Then next, we're going to know the value of 1 minus sine squared theta and our fundamental identities of the trigonometric functions. The 1 negative sine squared theta, this will be equivalent to cos squared theta. Okay, this will be equivalent to cos squared theta. Now after this, we're going to split each the numerator and denominator. So sine squared theta, then since cos squared theta is twice, we're going to split this one, becomes now cos squared theta times 1 over cos theta. Then plus, copy the numerator, sine squared theta, and copy the denominator, cos squared theta. And then we're going to simplify. Sine theta equals cos divided by cos theta is equivalent to what? So we have the fundamental identities. We have the formula tangent theta is equals to sine theta over cos squared theta. So this will be equivalent to tangent theta. How about 1 over cos theta? This will be secant squared theta equals to 1 over cos squared theta. So this 1 over cos theta, this will be equivalent to secant theta. Then sine squared theta over cos squared theta, this will be equivalent to tangent squared theta. Okay? Okay, we are now number 48 problem. Find the factor of the expression 4 minus tangent squared theta. So the given, this is called the trigonometric expression. Now we have the procedure. The first procedure is determine the factor of 4. So the factor of 4, we have 2 times 2, which is a perfect square. We have the other factor of this is 4 times 1, but we are looking for the perfect square. Next is tangent square is equals to tangent. If we're going to multiply tangent, we have tangent squared. So you have to do just only split this tangent squared into tangent and tangent. Our solution now, 4, copy first the given, 4 minus tangent squared theta equals, the first step that you're going to do is first make 2 parentheses, and then you're going to fill up this parentheses by writing the factor. The factor of 4 is 2 and 2. Then the sign is negative, so we have to do, and there's 2 parentheses, our sign is 1 negative and 1 positive. It's the technique, or either 1 positive here and negative, vice versa. There's no problem with that. And then the factor of tangent. The factor of tangent, we have tan and tan. So that's why we will write tangent theta and tangent theta. So this is our answer now in number 48. Next, number 49. Find the factor of the expression cosecant squared theta minus secant squared theta. So our solution, first we're going to factor the cosecant squared theta. We have to do is to split this cosecant. This becomes now cosecant theta and cosecant theta. If we're going to multiply this, becomes cosecant squared theta. Then secant squared theta is equals to, you have to do the factor, right? Just only to multiply, split this given secant and secant. And if we're going to multiply this, is correct, it becomes now secant squared theta. So this will be the factor. Then our solution is cosecant squared theta minus secant squared theta, copy the given. Then the first thing you do is to make two parentheses first, and you're going to fill up this parentheses by writing the factor. The factor of the cosecant squared here is cosecant theta, and cosecant theta to the other parentheses, and the sign is negative, so you write negative and one positive. And secant squared theta, the next term, so you have to do just write also the factor, and the factor is secant theta and the secant theta. So that's the answer for number 49.